Three configuration indicate that how the transistor should be used for the different application, right? So we know that for the application of your in this configuration, in this indicate that to find out the hybrid equivalent configuration, we have requirement of the 4 terminal, right? So 4 terminal. So for that purposes, we know that for transistor there is a 3 terminal, right? So we have to be taken out the one of the terminal as a common in between your input as well as output, right? So for that purposes we have to be done the three type of the configuration, that is common emitter, common base, and common collector configuration. In that configuration we have taken one terminal as a common between your input as well as output. Now see, we have seen the common emitter configuration. During this configuration we have taken this emitter terminal is in between your input as well as output, right? That's why it is called as common emitter configuration. We have to be find out the hybrid equivalent circuit of that particular configuration, that is either your common emitter, common base, or common collector. But in this case we have to be find out the hybrid equivalent circuit of the common emitter configuration, right? See, common emitter indicate that this is, we know that transistor have 3 terminal, collector, base, and emitter, right? So emitter is common indicate that this terminal is in between your input as your output. We have to be connected such a way that, okay, then it should be connected such a way that we have applying the base means we have applying the voltage in between your base and the emitter. That's why whatever the input voltage applied, that will be in between your base and emitter. That's why it is called as VBE. VB indicate that voltage applied between base and emitter terminal. Okay, at the same time there should be current flowing through the base terminal, that is a IB, base current, right? So see, VB indicate that input voltage, IB indicate that input current, right? So due to the input voltage and input current flowing through the device, it have to be output current, that is a current flowing through the collector. That's why it is called as IC, collector current, and the output voltage is coming in between your collector and the emitter terminal. That's why it is called as VC, this collector to emitter voltage, right? So in this case, your output current is I2 current, that is IC. Output voltage, that is a VC, that is V2 is equal to VC, right? See here, for CE configuration we have seen that the things V1 which is equal to input voltage, that is VB, okay. I1 is which is equal to IB, right, base current, right? And output current is a IC, that is IT is nothing but a IC, and output voltage, that is a VC. These are the things as we have to be seen. हे लक्षात येतंय का? V1 I1 V2 I2 कसं काढलं आपण ते, त्याची व्हॅल्यू प्लीज रिप्लाय करा.
Yes, sir.
Okay, so we doesn't do any other thing as like as H parameter. We have to be only, see, we have to be only changes the thing as like as here only. Means we have not written here, we have to be written on that already equation. In that case VB, in case of V1, for I1 we have to be written as IB only, right? For that V2 and I2 also same thing. See, we know that there are two equations. One is equation with respect to V1, that is dependent. We know that V1 and I2 that are the dependent variable, right? So all of the equation coming with respect to dependent variable, right? See, V1 which is equal to H11 I1 plus H12 V2, right? We know that H11 is nothing but it is nothing but a V1 upon I1. It is V1 upon I1 is called as input impedance, right? So for that purposes, we have to be write H as a common input impedance. So that's why we have to be written as a HI, and this is for the common emitter configuration. That's why it is written as a HI. Okay, so I1 current is nothing but a IB current. So that's why HI into IB plus H12. H12 indicate that H12 indicate that H12 indicate that it is the ratio of the V1 to the V2, right? So V1 to the V2 indicate that reverse voltage ratio, right? So HR, right? For that we have to be written as HR, and this is for the common emitter. That's why we have to be written as HRE, right? So V2, see, V2 indicate that VC, same we have to be written as a VC, okay? See, this is the thing with respect to the input voltage, right? So another equation for the dependent variable, that is I2. I2 is equal to H21 I1 plus H22 P2, right? H21 indicate that it is the ratio of the forward, output current to the input current, that is I2 divided by I1. So our I2 indicate that output, right? Output current to the input current, right? So it is a forward thing, means it is a forward current actually. So it is nothing but a HM, right? HM. For this is for the common emitter configuration. That's why it is written as a HAP. So I1 is nothing but a IB, right? See, I1 is nothing but a IB. We have to be written as IB plus H22. H22 indicate that is the ratio of the I2 divided by V2, right? I2 divided by V2 indicate that it is admittance, right? But it should be related to the output. That's why it is written as a output admittance. So O of that first taking H is common. So HO indicate that output admittance, and this is for the common emitter. That's why we have to be written as a HOE. Okay, phi2 indicate that pc, we have to be written as a pc. Okay, so your equation is output current I2 equal to IC, we have written as IC. So your whatever the equation coming is IC equal to HAP into IB plus HO into VC. Okay. Now H parameter of C configuration. Now we have to be find out the HI HRE. How we have to be find out? See here, I have explained here. See, Phi1 is nothing but a Phi B equal to HI into IB plus HRE into Phi. Okay. To find out the HI, what we have to do? Making other parameter as a zero, right? Making other parameter zero. So in that case, making Vc equal to zero. So Vc zero indicate that this all the things should be zero. So only Vb equal to Hi into Ib is remaining, right? So when we have to be calculate the Hi, in that case, Hi equal to Vb divided by this multiply going here as a divided. So Vb divided by Ib when Vc equal to zero. So Hi equal to Vb divided by Ib when Vc equal to 0, right? Hi equal to Vb divided by Ib when Vc equal to 0, right? So V upon indicate that resistance, so unit of it ohm. Okay. Now we have to be find out the HRE, right? So to find out the HRE, we have making this thing. This all the things should be 0. So that's why we have taken only either your voltage or current is 0. So making IB equal to 0, right? IB equal to 0 indicate that whole things should be 0. So HR equal to Vb divided by Vc, right? Making IB equal to 0. See here. Vb divided by Vc, IB equal to 0, right? V by V, it is both thing are voltage, that's why no unit, so it is unitless. Okay. Now this should be related to the equation number 1. Now we have seen the equation number 2. We have to be find out the two things, that is HAP and HOE here. Right, to find out the HAP, we have to be making the VC must be 0. So VC 0 indicate that both terms should be 0. So HAP equal to IC divided by IB when VC equal to 0. See, HAP equal to IC divided by IB when VC equal to 0. So both are correct. So it is a unitless. Okay, now we have to be find out the next thing, that is HO. To find out the HO, we have making other parameter as a 0. So IB equal to 0, it indicate that HO so this is 0 indicate that IC equal to HO into VC, right? So HO equal to IC divided by VC when we have to be making IB equal to 0. See, HO equal to IC divided by Vc IB equal to 0, right? It is opposite to that of this equation. That's why unit of this is ohm, opposite to that moho. Moho is unit for admittance. Okay, this is the thing. We have draw the same thing, only change. See, it is nothing but a equation of the P1 which is equal to H11 I1 plus H12, right? So only put out the particular value, means H11 indicate that HI, right? I1 indicate that IB, right? And other thing H12 indicate that it is a HRE, okay, into HRE into this thing, means V2 indicate that Vc. Okay, we have to put out the Vc. Same way, other equation is equal to I2 equal to H21 I1 plus H22 V2. Right, same thing. So for that purposes, we have to be written same way, same as we have to be written In this way, we have to be draw the same diagram and put out the value here. Okay, हे लक्षात आलंय का? रिवाइज्ड पार्ट होता त्यामुळे थोडं फास्ट घेतलं, लक्षात आलंय का?
Yes, sir.
Okay. Now we have to be seen the another revised part, that is hybrid equivalent circuit of the CB configuration. See, the difference between earlier configuration in this configuration is only that in this configuration base terminal is common. Common indicate that it should be seen in with respect to input as well as with respect to output. That's why it is called as common base configuration, right? So to see that configuration, we have making this base terminal. See, whatever the arrangement in a common emitter configuration, that are different because emitter terminal is in between input as well as output. But in this case, see, base terminal is in between your input and output. So all the things with respect to input and output, that are changes. Okay, see, this base terminal is in between your input and output. So that's why this is drawn in this way. In this way, this should be drawn, right? So see, we have applying the voltage through the input, that is V1 voltage. So V1 voltage is applied between your emitter terminal and base terminal. That's why it should be written as a VEB, right? VEB. But ABCD मध्ये B पहिल्यांदा असते. That's why it should be written as a VBE, right? Based to the emitter voltage. Okay, VBE. So after all that, this is the input voltage. So current flowing through the input, that is current flowing through the emitter terminal. That's why it is called as I. Right. At the same time, due to the application of input voltage, that is VB, and due to the input current, there should be generation of output voltage and output current. Now see, the voltage which should be coming between your two terminal, that is in between collector and base, right? Collector and base. That's why it is called as phi CB, phi CB. But same earlier region, it should not written as a VCB, it should be written as a VBC. Okay, VBC. It is the output voltage, and same way, whatever the current flowing through the output, that is with respect to collector. That's why it is called as collector current. Okay, so see, with respect to phi1 is nothing but a phi I1 is nothing but a I, and I2 is nothing but a I, sorry, I2 is nothing but a IC, and phi2 is nothing but a VBC, right? These are the things. Means whatever the equation we should be coming with respect to phi1, which is equal to H1 on I1 plus H1 to V2, right? Sorry, there are two equations, right? Phi1 equal to and the I2 equal to. So phi1 equal to H1 on I1 plus H1 to Phi2, right? So that during that equation we have to be only changes. We have to put out the only value. V1 equal to VB, I1 equal to IE, V2 equal to VBC, I2 equal to IC only. Okay. See, this is the value. We know that there are two equations with respect to dependent variable. Phi1 equal to H1 on I1 plus H1 to Phi2. So Phi1 is nothing but we know that Phi we have to be put out as a VB. Then H11 indicate that Phi1 upon I1, it is nothing but an input impedance, which should be written as a HI. For that common base configuration, we have to be written as a HIB. So HIB into I1. I1 indicate that IE. So IE plus H1 to V2. H1 2 is nothing but it is the reverse voltage ratio V1 to the V2, right? So that's why we have to be written as a HR for the common base configuration. See, for the common base configuration, that's why we have to be written as a HRB. Okay, so V2 is nothing but a VBC, right? So VBC we have to put out here. This should be related to the Q1 related. Q1 indicate that input voltage related equation, right? So for that purposes, there are two dependent variable equation. One is V1, other is for the purpose of I2. So I2 equal to H2 on I1 plus H2 to V2, right? This is the equation for the I2. We know that in this case, I2 is nothing but IC. So we have to be put out the value of the I2 over here, right? So IC equal to H21. H21 indicate that it is the ratio of the I2 divided by I1. It is nothing but output to the input. So output to the input indicate that forward, right? So HF for forward. So HF for it, and this is for the common base. That's why HFB, right? So into I1 indicate that IE plus H22. H22 is nothing but it is the ratio of the I2 divided by V2. I2 divided by V2 indicate that it is opposite to that of V1 upon I1, right? So that's why it is written as a admittance, right? So output admittance, that's why HO is written for it, and common base it is a B. So HOB and phi2, or the phi2 it should be as a phi-BC. Okay. So your equation is IC equal to HFB into IE plus HOB into phi-BC. This is the equation. Okay. Now we have to be found out this four thing, that is HIB, HRB, HFB and HOB, right? See, only thing is here changes that to find out the particular thing, we have making other thing as a zero. To find out the HIB, we have to be making phi-BC one parameter, that is either a voltage or the current, we should done as a zero. So to find out the HIB, we have to be making phi-BC equal to zero. So VBC zero indicate that whole HRB into VBC is equal to zero, right? This zero, HIB equal to VB divided by IE. Okay, this is equation should be coming with respect to HIB. So HIB is nothing but a VB divided by IE. When we have to be making VBC equal to zero. See, VB divided by IE, when we have to be making VBC equal to zero. To find out the HRB, right? To find out the HRB, Ayush, थोड़ा आवाज. See, to find out the HRB, we have making other parameter, right? Other parameter as a zero. So here current should be zero, indicate that whole thing should be zero, right? Whole thing should be zero. So HRB equal to phi divided by phi-BC, right? HRB equal to phi divided by phi-BC when I equal to zero. See, phi divided by phi-BC when I equal to zero, right? To find out the other parameter, that is I2 related parameter, it is nothing but IC equal to HFB into IE plus HOB into phi-BC. So to find out the HFB, see, to find out the HFB, we have making phi-BC equal to zero. Phi-BC should indicate that whole term should be zero, right? Zero. So HFB equal to IC divided by IE when phi-BC equal to zero. See, HFB equal to IC divided by IE when phi-BC equal to zero. See, IC divided by IE when phi-BC equal to zero, right? To find out the HOB, we have to be making I equal to zero, so whole thing should be zero. So HOB equal to IC divided by phi-BC, then we have to be making I equal to zero, right? So it is nothing but HOB equal to phi-BC divided by, sorry, HOB equal to IC divided by phi-BC. IC divided by PPC, then I equal to 0, right? This is the calculation for the HOD. See, it is as like an earlier diagram. We have to do earlier equation, that is V1 which is equal to H1 on I1 plus H1 to V2. जसं पुट केलं होतं ना त्याप्रमाणे फक्त इथे त्या आधार येणाऱ्या व्हॅल्यू याच्यात पुट करायच्या आहेत. इक्वेशन लक्षात आलं का? दिस कंप्लीटेड द रिवाइज्ड पार्ट. आजपासून सिलेबसला आपण सुरुवात करतो. लक्षात आलं काय?
Yes, sir.
Okay. See, we have now find out the hybrid equivalent circuit for common collector configuration. See, when we have to see the three type of configuration, that is common emitter, common base, and common collector. What it indicate that we have making the one of the terminal of the transistor taking as a common, and seen the whatever the hybrid circuit which we have to be formed, and we have to be find out the different thing with respect to HI, HR, etc. Right? See, for common collector configuration, we have making, see, there are three terminal of your transistor. One is your emitter, other is base, and third is collector. Now, to make the collector as a common terminal, we have making opposite way of, means connected opposite way of this transistor, right? See, emitter is upward, base is here, and the collector is here, right? So this case collector here, output also have the collector, input also have the collector, right? That's why it is called as common collector configuration. Okay. See, when we have making common collector configuration, in that case this is the base terminal as input terminal, and this collector terminal also as taking as a input terminal, right? So whatever the voltage applied between your base and in between base and the this collector terminal, right? So it is nothing but a voltage is applied between base and collector. That's why it is called as PBC. Okay, PBC. And whatever the current flowing through, it is in the base terminal. That's why it is a IB current. Okay, so Q1 which is equal to VBC, I1 equal to IB, right? So after all that, we have due to the application of VBC as an input voltage and due to input current IB, there should be generation of the output voltage VEC and the output current as a IE current. How it is? I'm telling you. See, the current flowing through the output terminal, that is the emitter current. That's why it is called as IE, and the voltage it should be coming across your emitter and the collector terminal. That's why it is called as PEC, but we doesn't tell as a VEC, it should be tell as a VCE, because in a BCD C is first, right? VCE is the voltage which should be coming with respect to your output, right? So see, output current is I2, means I2 equal to IE, output voltage V2 equal to VCE, right? Seen here. Uh, for CC configuration, Q1 which is nothing but a VBC, I1 is nothing but a IB, V2 is nothing but a, it should be written as a VAC, VAC or VCE. Both things are same, but we normally written as a VCE, right? VCE. Then I2 is nothing but a secondary current, that is IE. Okay, these are the things we know. That same way as like as earlier equation, we know that there are two dependent variable. One is v1, another is uh, I2. We have written as v1 which is equal to equation, that is h11 I1 plus h12 v2, right? So h11 is nothing but an input impedance, that is v1 upon I1, right? So for that purposes we have to be written as a hi, and this is for the common collector configuration. So that's why we have to be written as a HIC, right? HIC. I1 is nothing but a C IB. We have to be written as a IB plus H12. H12, what it indicate that? H12 indicate that it is the ratio of Q1 upon V2. Q1 upon V2 indicate that input to the output, right? We have requirement of the output to the input. That's why it is a reverse current, right? So it should be written as a HR. This is for the common collector. That's why HRC. And V2 indicate that whatever the output voltage coming, that is a VCE, VCE, VCE or VEC, right? So HRC into PCE or PEC. Okay, so your equation is coming VBC equal to HIC into IB plus HRC into PEC. Okay, this is the equation number one, right? Another dependent variable is equal to I2, right? With respect to our output, right? So we know that I2 indicate that output current. So output current is nothing but I. So for the I2 we have to be written as I. Now see I equal to I equal to H21 I1 plus H22 V2, right? H21 indicate that it is the ratio of I2 divided by 1. So it is a forward current, right? So for that purposes, we have to be written as a HF, right? HF. And this is for the common collector configuration. That's why it is written as a HFC. So I1 is nothing but a C. I1 is nothing but IB. We have to be written as a IB plus H22. H22 indicate that output admittance. So it is nothing but I2 divided by V2. So for that purposes we have to be written as a HO. For this is common collector HOC. So V2 is equal to VAC, VC or VC, VAC we have to be written, right? So your equation is IC equal to HFC into IB plus HOC into VAC. These are the equation. Now we have to be find out this four value, that is a HIC, HRC, HFC, and HOC here, right? To find out the HIC, what we have to do? Making other parameter as a zero. So making VEC equal to zero. So whole thing should be zero. So HIC equal to VBC divided by IB, right? So here HIC equal to VBC divided by IB. fin making phi is equal to 0. See, phi BC divided by IB fin making phi is equal to 0. Okay. Now to find out the HRC, what we have to do, making IB equal to 0, whole thing should be 0. So HRC equal to phi BC divided by phi C fin IB equal to 0. See, HRC equal to phi BC divided by this going as a divided. So HRC equal to phi BC divided by phi C fin IB equal to 0. See, VBC divided by VEC when I be equal to 0. Okay. To find out the other parameter as a HFC and HOC, we have seen this equation. To find out the HFC, we are making V is equal to 0. This term should be 0. See, this term should be 0, making that it whole thing should be 0. So HFC equal to IE divided by IB, right? IE divided by IB when V is equal to 0, right? To find out the HOC, what we have to do? We have making IB equal to 0, so whole thing should be 0. So HOC equal to IC divided by this multiply going as a divided. So HOC equal to IC divided by VEC when making IB equal to 0. So HOC equal to IC divided by VEC. IC divided by VEC when IB equal to 0, right? So drawing of this diagram same as like as H parameter. Okay, लक्षात आलंय काय? प्लीज रिप्लाय द्या, नसेल आलं तर तो पार्ट मी रिपीट कर. लक्षात आलंय का? प्लीज रिप्लाय द्या, नसेल आलं तर सांगा तसं. आलंय लक्षात?
Yes.
Okay. See, up to now we have seen that hybrid equivalent circuit for common emitter, common base, and common collector configuration, right? So we doesn't see only that thing. We have to be requirement of the voltage gain, current gain, as well as input impedance and output impedance of the particular transistor, right? So to find out that particular parameter, there should be a formation of the sum of the formula, right? So for that purposes, we have seen this diagram. See, the transistor amplifier circuit in the form of two-port network as shown in figure. See, this is the transistor. This is not only transistor circuit. This is the transistor amplifier circuit, right? Transistor amplifier circuit indicate that ट्रान्झिस्टरचा आपण ऍप्लिकेशन ऍज अँप्लिफायर म्हणून तो कसा यूज केला जातो, त्याचे कुठले कुठले पॅरामीटर आहेत, हाऊ इट शुड बी फाइंड इट, दॅट वी हॅव टू बी सीन formula for that. See, this is the transistor, this is the block diagram of the transistor amplifier circuit, right? So for that circuit, we have applying the voltage. This is nothing but a PS as the input voltage applied to the transistor amplifier, right? So due to that voltage applied, there should be one of the input impedance that should be formed with respect to your devices, that is called as RI. So whatever the voltage applied, it has some of the resistance that is called as series resistance, RS. So due to that voltage applied, there should be formation of the voltage as a V1 and the current flowing through the device, that is I1, right? This should be means V1 and I1 current flowing through the transistor amplifier circuit, right? So due to application of V1 and I1, that is voltage and current respectively, there should be formation of the output voltage, that is a V2 and I2, right? V2 indicate that output voltage, I2 indicate that output current, right? See, in this case, whatever the resistance with respect to your output, that is RO is called as output resistance. So during this diagram, we have to find out the four thing, that is input RI indicate that input impedance, RO indicate that output impedance, AV indicate that voltage gain, and the AI indicate that current gain, right? In this equation, see, whatever IL and I2 that are the same, means output current, see, I2 and IL that are the same, but see, whatever the load current flowing through the RL, that is actually output current, but same way IL and I2 are same, but IL is coming towards the RL, so IL is positive and I2 is equal to negative, because that should be flowing from out of this, right? So IL is equal to minus I2. लक्षात ठेवा, हे ज्यावेळेस आपण पुढे कॅल्क्युलेशन करतोय त्यावेळेस लागणार आहे. IL and I2 are that are same, but IL is coming towards the RL, that's why it is a positive, and I2 is going outside of this RL, that's why it is a minus. So IL equal to minus of I2. This is one of the equation we have required for further. Okay, so during this diagram, I'm explaining you the thing related to the transistor amplifier. See, transistor amplifier is the circuit which we have applying the input voltage as a V1 voltage. Due to the application of input voltage V1, there should be formation of the current I1. Means when we are applying the voltage V1, I1 current flowing through the device, that is in the transistor amplifier, right? So due to the flowing of input current V1 and input voltage V1 and current I1, there should be output voltage and output current should be generated. So output voltage is called as V2 voltage and output current is called as I2. And during this, see, whatever the output resistance is RL, when the current flowing through the output, that is IL current. But see, IL current is considered as a positive because it should be coming towards the RL, right? त्या पॉइंट कडे येत असेल तर तो पॉझिटिव्ह म्हणायचा, पॉइंट पासून अदर दुसरीकडे जात असेल तर तो मायनस. सो IL equal to minus of I2, right? See, these are the thing with respect to this configuration. We have to be find out the value of the RI, RO, AV and the AI in a session. In this session, only one thing, one or two things will be completed. See here. See, above figure shows that the hybrid equivalent circuit of the transistor amplifier circuit, right? See, whatever the thing we have seen in earlier, means up to the last lecture, in that configuration, how the transistors should be used, whatever their way, that we have seen in up to now, right? We know that there are three way of the working of your transistor, that is common emitter, common base and common collector, right? So for that equation we have to be find out the different value, that is HIE, HAP, etc value we have to find out. Why it is find? See, the reason that it is the gain. तर मला सांगायचं काय सांगतो की ज्यावेळेस आपण ट्रान्झिस्टर पाहिले ना त्यावेळेस तिथं काय पाहिलं की गेन कोणाची जास्त आहे. गेन जास्त आहे कशासाठी पाहतोय, लक्षात घ्या की अँप्लिफायर म्हणून यूज करायचं आपल्याला. लक्षात घ्या, जर अँप्लिफायर म्हणून वर्क करायचं असेल तर गेन मॅक्झिमम पाहिजे. गेन म्हणजे काय, लक्षात घ्या, मी माईकवर बोलतोय, व्हॉट आय एम टेलिंग समथिंग इन अ माईक. इन दॅट केस व्हॉट एव्हर द सिग्नल कमिंग फ्रॉम माय सेल्फ, इट इज अ small value signal, right? Small value signal. So for the purpose of loudspeaker, it should be must be amplified, right? That's why we have to be connected mic signal to the amplifier, right? So amplifier amplified signal and that should be sent towards the loudspeaker, and it increases the gain. Indicate that सिग्नलची स्ट्रेंथ जर स्मॉल असेल ना, ती वाढवायचं काम तुमचं अँप्लिफायर करतो, लक्षात घ्या, राईट? तर त्यासाठी काय काय पॅरामीटर आहेत, कुठलं कॉन्फिगरेशन आपल्याला यूज करता येईल, कॉमन मीटर का कॉमन बेस का कॉमन कलेक्टर. आपण जे डिफरंट व्हॅल्यू काढल्या ना, त्या व्हॅल्यूवरनं ते कळतं की कुठलं कॉन्फिगरेशन यूज करायला पाहिजे आणि त्यातनं कुठली गेन जास्त असेल. ओके, सो वी हॅव सीन दॅट there are three configurations, that is common emitter, common base and common collector. I'm telling you something generalized term with respect to these three configuration. That is, in case of your common emitter configuration, there should be maximum gain. See, I'm telling you maximum gain with respect to all of the three configuration, but there are some of the voltage or current that are the different. Mean, in case of your common emitter amplifier, whatever the gain coming, that should be with respect to the voltage, right? So to increase the gain with respect to your voltage, in that case we must use the common emitter configuration for your application, right? So common emitter amplifier normally used for the purpose of pre-amplifier. I'm telling you in a unit number 7, right? Whatever the application of this, that should be coming in a unit number 7, that is a feedback amplifier chapter. That in that chapter we have to be seen that why the common emitter should be used there, right? See, combinator configuration give the amplification of the signal with respect to voltage. Means it does not amplify large amount of signal. म्हणजे इनपुट जे अप्लाय केले ना, ते काही प्रमाणात इम्प्रूव्ह होतं, लक्षात घ्या. म्हणजे आपण जर स्मॉल आवाजात बोललो तर इन्क्रीज होतं, पण जास्त आवाजात नाही. जास्त नाही म्हणजे अप टू सम स्मॉल एरिया. ओके, this signal should be going. Okay, now we have seen the thing with respect to the other parameter, that is common base configuration. When we have to build the common base configuration, in that case it has some of the disadvantages, or it should have less input, high output impedance. That are the thing. That's why this should not be used for the purpose of amplifier application. HIB means common base configuration, common collector configuration. This is the majorly used configuration when we have to be requirement of the current amplification. See, current indicate that driving force, right? सो लक्षात घ्या, आता जनरलाइज टर्म सांगतो तुम्हाला. ज्यावेळेस आपण जास्त म्हणजे तुमचे जर पाहिलं असेल ट्यूब वगैरे लागत असताना, ट्यूब ज्या खेडेगावामध्ये आधीच्या काही प्रॉब्लेम व्हायचे बा, म्हणजे ज्यावेळेस आपण लाईट ट्यूब लावली ना, बऱ्याच वेळा अशी बंद चालू म्हणजे लागत नसायची भरपूर वेळेस. त्यावेळेस आपण म्हणायचो व्होल्टेज कमी. ऍक्च्युली व्होल्टेज कमी नसतं, करंट कमी असतं त्या केसमध्ये. लक्षात घ्या, करंट कमी असल्यामुळे तेवढा ड्रायव्हिंग जो त्याला लागणारा जो करंट असतो तो कमी असल्यामुळे तो लागत नाही. लक्षात घ्या. ओके, म्हणजे पॉवर पॉवर म्हणजे काय असतं, ऍक्च्युली करंट असतो. लक्षात घ्या, नॉट अ व्होल्टेज. ओके, सो I'm telling you with respect to the current. So in case of your common collector configuration, there should be current amplification of the signal should be done, right? See, when we have recurrent of the large amount of the power amplification, in that case we must use the common collector configuration. Okay, this is the configuration of the transistor which will does the amplification of your current. That current म्हणजे पॉवर आहे. लक्षात घ्या, म्हणजे जे स्ट्रेंथ जर जास्त इनपुटला जो व्हायचा ना त्याची वाढवायची असेल, त्या ठिकाणी कॉमन कलेक्टर कॉन्फिगरेशन लक्षात यूज करतो आपण. लास्टचा जो आपल्याला सातवा आहे ना, तो पॉवर अँप्लिफायरचा. लक्षात घ्या, त्याच्यामध्ये हे दोन्ही कॉन्फिगरेशन म्हणजे कॉमन इमिटर आणि कॉमन कलेक्टर हे दोन्ही पण यूज केले जातात. आपण कसे ते त्यावेळेस, फक्त आता एवढं लक्षात ठेवा की जे ऍप्लिकेशन आहेत ना याची, या 3rd चॅप्टरचे 7व्या चॅप्टर मध्ये, त्यावेळेस मी तुम्हाला रेफरन्स सांगेन. ओके, सी, these are the thing with respect to configuration of the transistor CE, CB, CC, application of CE and application of the CC. CE indicate the pre-amplifier, म्हणजे amplifier जर जास्त करायचं असेल ना, त्यातला स्टार्टला एका लेवल पर्यंत इन्क्रीज करण्यासाठी आपण प्री अँप्लिफायर म्हणून कॉमन इमिटर अँप्लिफायर यूज करतो. आणि जर जास्त अँप्लिफाय करायचं असेल तर कॉमन कलेक्टर यूज करतो. Now we have to be find out the 4 thing, that is AI, AV, then RI and RO. AI indicate that current gain, right? Current gain. AV indicate that voltage gain. Then RI indicate that input impedance. RO indicate that output impedance, right? So we know that determination of current gain. Current gain indicate that, see, any of the gain is nothing but it is the ratio of the output to the input. So current gain indicate that it is the ratio of the output current to the input current, right? It indicate that current gain. So in this configuration, AI indicate that current gain. To find out the current gain, here is a input. Input indicate that Q1. When Q1 is flowing, in that case, whatever the voltage Q1 flowing, there should be current flowing, that is I1. See, I1 current flowing when V1 voltage flowing. So here input current is I1, output current is nothing but a I2. See, I2. I2 is the output current. Okay, that should be flowing here. See, AI equal to I2 divided, see, IL, this is actually IL, but why it should be written as a IL, I am telling you. Whatever the thing coming with respect to input as well as output, that is a input voltage flowing. Due to that input voltage, there should be current flowing. That current is considered as I1. Q1 voltage flow असल्यामुळे I1 करंट फ्लो होत असतो, म्हणजे इनपुट करंट I1 झाला, राईट. आउटपुट करंट म्हणजे कोणता आहे, तर आउटपुटला पाहायचं होते IL पहा IL. आणि ज्या IL का पाहतोय आपण याला म्हणतोय, कारण तो IL हा करंट RL मधून फ्लो होतोय, म्हणजे आउटपुट करंट तुमचा IL असणार आहे IL, पण तोच मायनस I2 काय हे सांगतो. एक करंट तुमचा या डिव्हाइस मधून फ्लो होणारा करंट कोणता आहे पहा, तर या डायग्राम मधून दिसेल तुम्हाला, राईट. IL करंट हा तुमच्या आउटपुट मधून फ्लो होतोय, म्हणजेच तुमचा रेशो AI इक्वल टू काय येईल, IL डिवायडेड बाय I1. सी, AI इक्वल टू IL डिवायडेड बाय I1. पण तुम्हाला मी सांगितलं इथंच IL म्हणजेच काय होतं, IL म्हणजेच काय होतं, करंट टूवर्ड्स द RL कडे येतोय. IL आणि I2 सेम आहेत, पण IL हा RL कडे येतोय, त्यामुळे तो पॉझिटिव्ह आहे, आणि I2 इथपासून ऑदरला जातो, म्हणजे नोड कडे येणारे करंट पॉझिटिव्ह कन्सिडर जातात, नोड कडनं बाजूला जाणारे करंट निगेटिव्ह. सो IL इक्वल टू minus I2. So we have to be put out wherever IL coming, we have to be written as a minus I2, right? See here. So AI equal to IL divided by I1, right? But from circuit diagram, see in above circuit diagram, IL equal to minus I2. हे कसं आलं हे लक्षात येतंय का? मी तुम्हाला आता सांगितलंय. प्लीज सांगा मला. IL equal to minus I2 का आहे हे लक्षात आलंय का? प्लीज नाही लक्षात आलं ना? सांगतो. See, this is the diagram of the determination of amplifier parameter, right? So during that parameter, we have seen that Phi1 voltage will flowing through the device. In that case, current flowing through the device, that is input current, that is I1. And due to that, Phi1 and I1 flowing through the circuit, there should be generation of output voltage and output current. So Phi2 is the output voltage and I2 is the output current. But this current is traveling from IL, right? IL to the towards the device. That's why whatever the current flowing through the REL, that is output current, right? Output current. So REL is the output impedance. So IL is the load current, that is output current. So IL is the output current. So whatever the gain, AI equal to ratio of the output to the input. So IL divided by I1 is nothing but a ratio of the output to the input. See, IL divided by I1. But we have already known IL is whatever the current going towards the node, that's why it is a positive. It should be, means IL and I2 are same, but towards the node, it should be considered as a positive. Going outside the node, it should be considered as a negative. So IL equal to minus of I2. Okay, आता लक्षात आलंय का? IL equal to minus I2 का आहे? Please reply there.
Yes, sir.
Okay. So in that equation, we have written as AI equal to IL by I1. But when we have to be seen this thing, right, in a circuit diagram, in that circuit diagram, we have to be seen IL as a minus I2. So wherever IL is coming, we have put out as a minus I2. So AI equal to minus I2 divided by I1. This is the equation number 1, right? This is the thing we have to find out with respect to current gain. But see, we have seen the same thing with respect to H parameter, right? Seen that with respect to H parameter. So this is the thing with respect to current. That's why we doesn't use the equation of U1 equal to H1 on I1 plus H1 to I2. We have to be used here term as a I2. So I2 equal to H2 on I1 plus H2 to Phi2, right? So H2 to 1, sorry, H21 indicate that it is the forward current. So I2 divided by 1, right? So for the H21, we have to be written as a HF, and I1 as it is HF into I1 plus H22 indicate that it is the output admittance. So HO into Phi2. This is the thing. Means I2 equal to HF into I1 plus HO into Phi2. Okay. But see, with respect to this term, Phi2, see, when we have to be find out the Phi2, we know that Phi2, Phi equal to IR, you know that Ohm's law, Phi equal to IR, right? So Phi2 equal to I related current and resistance is IL and RL, right? So for the V2, we have to be written as a Ohm's law equation, Phi equal to IR, right? So Phi2 equal to IL into RL, put out here. See, Phi2 is equal to IL into RL. हे लक्षात येतंय का कसं आलं ते? आपल्याला माहिती आहे ओम्सला फी इक्वल टू IR असतं, बरोबर? तर आता इथं जर Phi2 जर फाइंड आउट करायचं असेल तर Phi2 इथं आलं, त्याच्या रिलेटेडचं करंट अँड रेजिस्टन्स IL आणि RL आहे. सो Phi2 इक्वल टू IL and RL, वी हॅव टू बी रिटर्न. लक्षात आलं आता?
Yes, sir.
Okay. Phi2 is equal to IL into RL. But we know that we have already found out IL is nothing but a minus of I2. So for that IL, we have to be written as a minus of I2 into RL, right? This is the thing. So Phi2 equal to minus of I2 into RL. So for the value of Phi2, we have to be written in equation number 1. We know that Phi2 equal to minus I2 into RL. So we have to be written as a Phi2 minus I2 into RL here. So equation is same, I2 equal to HF into I1, I2 equal to HF into I1. Other thing, plus HO into V2. For that V2 we have to be written as a minus I into RL. So HO as it is for this thing means V2 we have to be written as a minus I2 into RL. Okay, so equation is coming I2 equal to HF into I1 plus HO into bracket of minus into minus I2 into RL. Okay, so for that we have to be rearrange this equation. Okay, so in that equation we have to be taken out the HF into I1. See, HF into I1 as it is, HF into I1 as it is, and all other things are switched over there, right? I2 as it is ठेवलं, sorry, HF into I1 as it is इकडेच ठेवलं आणि HO इंटू ब्रॅकेट ऑफ मायनस I2 इंटू RL म्हणजे हे सगळंच मायनस झालं, बरोबर. मायनस होतं पलीकडे जाऊन प्लस होईल, म्हणजेच I2 प्लस HO इंटू I2 RL, HO इंटू I2 इंटू RL आणि विच इज इक्वल टू HF इंटू I1. हे लक्षात येतंय का? एक क्वेश्चन पहा, लक्षात येतंय का तुमच्या कसं येतंय ते. इथं आपण काही केलेलं नाहीये. I2 इक्वल टू HF इंटू I1 प्लस HO इंटू मायनस I2 इंटू RL हे इक्वेशन होतं आपल्याकडं. या इक्वेशन मध्ये आपण काय केलं, HF इंटू I1 ऍज इट इज ठेवलं इथं, लक्षात घ्या, ऍज इट इज इथं ठेवलं. आणि इथे जे प्लस आहे ना इक्वेशन ऍक्च्युली मायनस आहे. कसं मायनस आहे सांगतो. HO इंटू मायनस I2 इंटू RL इंडिकेट मायनस येते इथं. HF इंटू I1 मायनस ऑफ HO I2 RL येते, मायनस ऑफ HO I2 RL. ओके, हे इक्वेशन आलं. तर हे मायनस होतं ते पलीकडे जाऊन प्लस झालं, म्हणजे I2 प्लस HO I2 RL. ओके, विच इज इक्वल टू HF I1. आता लक्षात आलं का? हे इक्वेशन लक्षात आलं का? आणखीन एकदा सांगतो, लक्षात घ्या. लक्षात घ्या, I2 इक्वल टू HF इंटू I1 प्लस HO इंटू मायनस ऑफ I2 इंटू RL हे इक्वेशन होतं. लक्षात घ्या, या इक्वेशन मधला HF इंटू I1 ऍज इट इज ठेवला आपण आणि काय करणार आहोत आपण, HO इंटू ब्रॅकेट ऑफ मायनस I2 इंटू RL, मायनस आहे इथे येईल, म्हणजेच मायनस ऑफ HO I2 RL असं इक्वेशन आहे ते. मायनस होतं पलीकडे जाऊन प्लस होईल, म्हणजे I2 प्लस HO इंटू I2 RL. Okay, HF into I1 as it is, HF into I1 as it is. So in that equation both I2 is common, so taking I2 as a common, so here 1 is remaining, so 1 plus HO into RL. Okay, plus HF into I1 as it is, right? So in this equation we know that current gain is nothing but output divided by input, right? So in that equation we have taking I2, this I1 multiply going as here as a divided, so I2 divided by I1, see, I2 divided by I1 which is equal to HF as it is, this is the thing multiplied going here as a divided, so HF divided by 1 plus HORL. So your equation is AI equal to AI, this is nothing but a current gain, output current divided by input current, so which is equal to plus HF आहे ऍक्च्युअली तर मायनस मायनस चुकून झालं होतं, त्यामुळे ते प्लस करण्यासाठी मी विचार केलाय. सो प्लस HF डिवाइडेड बाय 1 प्लस HORL, दिस इज द इक्वेशन कमिंग विथ रिस्पेक्ट टू द करंट गेन. हे लक्षात आलंय का?
Yes, sir.
ओके, गिव्ह द अटेंडन्स. Roll number 1. Roll number 1, 2,
Present.
3,
Present, sir.
4, 5, 6,
Yes, sir.
7,
Yes, sir.
8,
Present, sir. Present.
9, 10,
Present, sir.
11, 12,
Yes, sir.
13, 14,
Yes, sir.
15, 16, 17, 18,
Yes, sir.
19, 20, 21, 22,
Yes, sir.
23, 24,
Yes, sir.
25,
Present, sir.
26,
Yes, sir.
27,
Yes, sir.
28,
Yes, sir.
29, 30,
Yes, sir.
31, 32,
Present, sir.
33, 34. Okay, 34, 35,
Present, sir.
36, 37, 38.
Yes, sir.
Okay, absent number सांगतो 1 4 5 7 9 11 13 15 16 17.
16 present.
Okay,
1 present, sir.
7 present, sir.
19 20 21 23 29 31 34 36 37. ओके, परत एकदा सांगतो 4.4 5 9 11 13 15 17 19 20 21 23 29 31 34 36 37. ओके,
Sir, 28 present आहे.
कि 20
8.
28 प्रेझेंटच आहे मग.
सर आवाज ऐकायला नव्हता, सॉरी.
ओके ओके, स्टॉप करूया आपण. काय प्रॉब्लेम असले तर विचारा जावा. हा, आणखीन एक टेस्ट माहित आहे ना, युनिट टेस्ट.
Yes, sir.
Yes, sir.
हा, युनिट टेस्टची तयारी करा. काय प्रॉब्लेम असला तर विचारा जावा मला. ओके.